My dear students, I welcome all of you for this session on Internet of Things. In this session, let us study about one of the important microcontrollers that acts as an endpoint in an IoT, I mean Internet of Things projects. The microcontroller we are going to discuss in this session, I mean the microcontroller to which you will be introduced in this session is an Arduino. Let us have a look at agenda of this session. At first, I will give you an introduction to Arduino. Means you will learn about the microcontroller Arduino. Once you come to know what actually Arduino, you will see why Arduino is preferred when there are other microcontrollers available in the market. After discussing why Arduino is preferred, okay, we will have a look at which Arduino suits our project. Means in the market there are several variants of Arduino. Among those variants, which Arduino board suits best? Next, after getting familiar with the basics of Arduino, we will explore one important or the most familiar one. I mean to say the microcontroller board that is Arduino Uno, okay, which is used in most of the projects. I'm, I mean, after we will become familiar with Arduino, okay, I mean basics of Arduino, we will have a look at one of the variant of Arduino, that is Arduino Uno. This Arduino Uno is used in the majority of the projects when compared to other variants. After exploring Arduino Uno board, okay, we will see what are the things that Arduino can do. Okay, so this is about the agenda. I repeat, first I will introduce you to Arduino microcontroller. Then I will tell you why Arduino is preferred when there are other microcontrollers available. Next, among the variants of Arduino, which Arduino board is to be preferred, is to be chosen. In the next section, we will explore the important Arduino board that is used in majority of the projects, that is Arduino Uno. And then we will wind up this session with looking at the things that Arduino can do. Now let us see introduction to Arduino. See, Arduino is an open source advancement prototyping platform which depends on simple to utilize equipment and programming. I repeat, Arduino is an open source advancement prototyping platform which depends on simple to utilize equipment and programming. See, when I say an open source, okay, the software or an IDE, that is integrated development environment, where we write a code, and the code after compiling which we will upload to Arduino is an open source. Let me repeat once again. Here an open source means the software, that is an IDE, okay, through which we are going to write a source code, and that source code after compiling which we will upload to Arduino microcontroller is an open source. Got it? And that IDE we call as Arduino IDE. So next, when I say simple to utilize, okay, see, you can interface Arduino to a computer using a simple USB cable. Got it? Means along with Arduino microcontroller, you will get a USB cable. Through that USB cable, you need to interface Arduino to computer. So it's very simple to utilize. And when I say simple programming, okay, see, the Arduino programming constructs resemble C programming constructs. Okay, so already you're familiar with C, C++, Java, and other programming languages, right? So Arduino resembles C programming. So it's a simple one. So got it? So what actually an Arduino? It's an open source. I mean, an IDE is an open source advancement prototyping platform which depends on simple to utilize equipment. I mean, you can interface Arduino to computer using a USB cable. And programming, it's simple, means it's like C programming. Now, see, let me tell you some of the basic programs, okay, or some of the basic tasks that an Arduino can perform. I mean, you can write a source code for some simple task using an Arduino IDE, and that code compile it and then upload to Arduino board. Okay, so some of the basic tasks, simple tasks here are listed are detecting the power of light. I mean, you can interface some sensors to Arduino microcontroller which detects the power of light. Okay, then also you can interface some buttons, okay, to an Arduino microcontroller. So when you press or release a button, the event is triggered, and that triggered event can be detected by Arduino. So whenever an event is triggered, what action should be taken, that we can program it. Okay, so also an Arduino you can use to detect a Twitter message. Clear? So now also Arduino, whether it detects power of light, or it detects an event triggered by button, or it detects a message from Twitter. So it can respond to this. So the response is what I've shown on slide, like running the engine, or the pressing the button might be to turn on the LED, or second time when you press the button it might be turning off the LED. And when a Twitter message is detected, we can send some data through online. Clear? So this is some basic, I just shown some basic tasks that Arduino can perform. Apart from this basic task, Arduino can even perform some complex task. So I said Arduino is a microcontroller. So how to give an instruction to microcontroller that is on the Arduino board. Okay. So to frame an instructions, I need to use some programming language. Okay. And for that programming language, I need an environment, IDE. So I said that is an Arduino software which you call Arduino IDE, which is an open source. So using this Arduino IDE, you can program the microcontroller to perform some set of instructions. After writing a program source code in an Arduino IDE, compile it. On successful compilation, you can upload to Arduino board. I mean to the microcontroller on the Arduino board. See, microcontroller is like a mini computer, microcomputer. Okay, it's like a microcomputer. Okay, I mean to say, don't get confused. No, I'm just comparing it with a microcomputer. See, every computer has a processor that processes some task that exists set of instruction, right? So similarly, a microcontroller Arduino Uno also has a processor, and that processor is Atmega 328P. I repeat, the processor that is an Arduino Uno is Atmega 328P. And we know what is processor CPU. It's nothing but brain of a computer. Clear? Now, Intel processor, AMD processor, right? Similarly, Atmega 328P is a processor. So this Atmega 328P is a processor from Atmel family. I mean, it's an Atmel registered low power CMOS 8-bit AVR, I mean automatic voltage regulator microcontroller with 32K bytes in system programmable flash. I mean to say, Atmega 328P is a processor from Atmel registered family. It's a low power CMOS. It's an 8-bit processor. It's an AVR microcontroller, I mean automatic voltage regulator. And it has a 32K bytes in flash. Hence, it has a 32K bytes flash memory within it. Got it? So clear? So Atmega 328P is a processor from Atmel register family, which consumes lower power, which is an AVR microcontroller with 32 kilobytes flash memory within it. So See, so I can call Arduino to be a small computer. Okay, Arduino is nothing but a small computer that we can program to read information from the world around us and send commands to outside world. See, when I say Arduino can read information from the world around us, means how it reads information from the world around us? Because we are going to interface, we are going to connect several sensors, several devices and components to the Arduino. Got it? So, as we are going to connect several sensors, several devices to Arduino, it can read information from outside world. So, Arduino is a tiny computer that we can connect to electrical circuits. Got it? Now, we came to know what actually Arduino. So now let me see. In market there are several microcontrollers available. But why we need to prefer Arduino? First I said it's an open source, right? So an IDE, there is a software through which I am going to write a source code, and that source code compiled and uploaded to microcontroller. Okay, it's an open source. I mean, why the first point why I prefer Arduino means because Arduino IDE is an open source. I repeat, why Arduino? Because Arduino IDE is an open source and it's flexible to customers. See, when I say Arduino is flexible means, okay, it has both digital pins as well as analog pins. Okay, we'll have a look at this digital pins and analog pins in the coming slides when we look at Arduino, when we explore Arduino board. Okay, Arduino is flexible because it has variety and it has a number of digital pins and analog pins. SPI means serial peripheral interface and PWM outputs, I mean pulse width modulation. So I repeat, one reason I prefer Arduino is because Arduino IDE is open source and Arduino is flexible. Because the other reason is Arduino is flexible because of offering a variety of digital and analog pins. SPI pin, serial peripheral interface, and pulse width modulation outputs. The third reason is Arduino is easy to use. You can simply connect Arduino to a computer using a USB cable. Okay, after connecting Arduino to a computer, the Arduino and computer interacts, communicates using serial protocol. Okay, so third reason is Arduino is easy to use. And one more thing with respect to cost, Arduino is inexpensive, around 500 rupees per board, with free authoring software. That is Arduino IDE is an open source. And third, last and one more reason why I prefer Arduino is that, see, there is an online community which is growing where we can find lots of source code already available. I mean to say, I want to develop some project, okay? The part of that project which I'm going to develop, okay, might already been developed and might be available, okay, and the source code of that project is already available in this growing online community. So you need not have to write a code from scratch. Already readily available codes are in online community. And one more thing, if you have any doubt, okay, how to program an Arduino, you can just post some comments in this online community. Next, see, Arduino is not dependent on any one specific platform, like only on Windows or only on Linux. Okay, it's a cross platform. I mean, it works on Windows, it works on Mac, it works on Linux platforms. Means an open source software, that is Arduino IDE, is available for all this varying platforms like Windows, Mac, or Linux. And one more reason why I prefer Arduino is because of programming. It's very simple. It's very clear. I said it resembles C language. It's a C programming. So this is why we need to prefer Arduino. So now let us have a look at which Arduino variant we need to choose among several variants. See, there are many Arduino boards. Say for example Arduino Uno, Arduino Mega, Arduino Micro, Arduino MKR1000, and Flora, which is Arduino compatible from Adafruit. Okay, but among 99% of projects, we see Arduino Uno as the microcontroller to be used. Okay, and hence we prefer Arduino Uno among the variants of Arduino. Now let us explore Arduino Uno motherboard. Sorry, Arduino Uno learning board. Okay, Arduino Uno board. See, this is what you're viewing on the slide is an Arduino microcontroller, Arduino Uno. Okay, you can see there are there is an Atmega 328P processor, some pins. Okay, let in next slide. Okay, I will show where is processor, where are digital pins, where are analog pins, where are SPI, where are PWM outputs. Okay, and some other pins. Okay, so now look at this slide. See at the right side. Okay, you can see pins number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the pins numbered 0 through 13 are digital pins. Okay, digital pins. I mean to say this pin values, okay, can be either 0 or 1 or high or low. Or in other words, in terms of voltage, when I say 0 volts or 5 volts. Okay, so there are totally 14 digital pins as you can see. Again, just look at the right side. The pins number 0 through 13, they are digital pins. Okay, among these digital pins, okay, just observe the pin numbers 11, 10, 9, 6, 5, 3. I repeat the pin numbers 11, 10, 9, 6, 5, 3. They are PWM output pins. Means there are 6 pulse with modulation outputs. Okay. Also, you can see some serial peripheral interface pins, right? Say, for example, pin 13, 12, the SPI pins. Okay, also 11, 10. There are two more pins. Okay, so just observe digital pin 0, 1. This pins, digital pins 0, 1, can be used for serial communication. Okay, can be used for serial communications. Okay, one pin, that is digital pin 1, acts as transceiver, and digital pin 0 acts as receiver. Okay, so now we have seen 14 digital pins, 6 PWM output pins, some SPI pins, and serial transmission pin TX, and receiver pin RX. At the left side, you can see there are 6 analog pins, right? Just observe at the left side, there are pins labeled as A0, A1, A2, A3, A4, A5. There are 6 analog pins. Okay, so uh, the arrow which shows a microcontroller. Okay, that's an Atmega 328P processor. Okay, it's a microcontroller. I can call it as a microcontroller rather than a processor. Okay, that's a microcontroller which has the processor Atmega 328P. Clear? Which has digital analog pins, PWM output pins, SPI pins, everything. Now, the DC power jack, what you are seeing, okay, is to turn on the Arduino. Okay, is an adapter through which you will power on the Arduino. The USB port, what you are seeing, okay, through which we are connecting to computer. Okay, so take a USB cable, plug one end of the USB cable to computer and the other end to this Arduino. Through this USB cable, okay, the Arduino and computer will communicate. And you can see there is a crystal clock oscillator, 16 megahertz crystal clock. Okay, and the reset button means, see, it's a microcontroller, right? So when you turn on an Arduino, the program that is uploaded to controller will start executing. Okay, start executing. See, after some time, if you press the reset button, okay, after some time, if you press the reset button, whatever the program, okay, on the microcontroller that is being executed will restart from first instruction. So I mean reset button is to restart the program on the microcontroller. Clear? So, and you can see there are some pins which require 3.3 volts output, 5 volts output, and the pins which should be grounded, and a pin which is not having any connection and all. Okay, and some pin requires input in the range 7 to 12 volts. Okay, this is what I told. I told about microcontroller, digital pins, the 14 digital pins, right? uh, we have seen pulse width modulation outputs. We have seen transmission and receiver pins. Okay, one more thing, LED attached to digital pin 13. See, just observe the slide at digital pin 13. Digital pin 13. There is an LED. Okay, at digital pin 13, you can see an LED which is interfaced to microcontroller through this digital pin 13. So this is for debugging of the Arduino program. We call sketches. Sketches nothing but Arduino program. So we have seen analog pins. I showed about power pins, reset button. Okay. So how to power on LED? Okay. Here, see one thing you can power on Arduino. So power on LED. Okay. Let me say power on LED means there is an LED and this Arduino that will be on until the Arduino controller is in on state. Clear? Power on LED. It's an LED which will be on until Arduino is in on state. I said USB jack, power jack, right? Now, so I think so you got familiar with this Arduino Uno board, right? We can see a microcontroller, 14 digital pins, 6 analog pins, 6 PWM output pins, SPI pins, transmission, receiver, reset button, USB port, crystal clock, power jack, power on LED, and other things. Got it? So now let me see applications of Arduino Uno. I mean, what are the things that Arduino can do? See, one simple application is you can make use of Arduino Uno controller to control an LED. Means you can interface an LED to Arduino. You can make LED to blink, or you can make LED to glow as long as you require. Okay, so you can control an LED. This is the one simple thing that Arduino can do. Okay, and sometimes you want to display some message. Okay, you can interface LCD display to Arduino microcontroller, and you can program the controller to display some message on it. I repeat, you can interface an LCD display to Arduino microcontroller, and you can program the microcontroller to write some message to LCD display. You can control DC motors or servo motors. Okay, you can use Arduino Uno to control motors. Next, you can read data from the outside world. See, you can interface sensors, say for example temperature sensors, humidity sensors, or moisture sensors. Just interface to Arduino microcontroller, and you can program Arduino microcontroller to read data these sensors generate. That is how we can read data from outside world. One more thing, there is a special sensor, what we call motion sensors. Okay, one simple, there is some sensor available in market now, PIR, passive infrared sensor, PIR motion sensor. Okay, so using motion sensor, okay, I mean to say, if you have interfaced motion sensor to Arduino, you can detect any movements in the surroundings of Arduino. Okay, next, uh, light sensor. If you, there is something LDR sensor, okay, light sensor. When you interface light sensor to Arduino, you can detect the intensity of light in the surrounding. Okay, and I said humidity and temperature sensors can also be interfaced. Ultrasonic sensors to detect the level of sound. Okay, so I mean, using such sensors like motion sensor, light sensor, humidity and temperature sensor, ultrasonic sensor, Arduino Uno can read data from outside world. Okay, so these are things that Arduino can do. Not only limited to these things, you can program Arduino as per your project. Got it? Clear? So now let us see. Let us. This is about this session. Let me wind up. Thank you for listening.